Which one?
That's a good question. Mine or yours. We can. It's all live. Let's just try and turn it off and on again.
So just on and off, right? Little button below. Again, okay, should be on.
So we have one microphone, and I guess we have the other one. Perfect.
Yay.
All right, that was a live troubleshooting right there.
Hot fix in production.
Right,
well done.
right. Yeah. Okay. Welcome back to Build Propulsion Lab at JCON Europe, coming to you live from Cologne, Germany, and my next guest, who is also my friend, is Alina. Yurenko, welcome.
Thank you so much for having me. Finally, we are doing this.
I've been following you through all the conferences in the last 2 weeks. We met at Devox France, and then we met at Devox UK, and then finally, I have the pleasure and the honor to host you at the Build Propulsion Lab here at JCON. Welcome.
Pleasure is mine. Thank you so much.
So, I guess the topic of conversation is the one and only that is GraalVM. You are the developer advocate for GraalVM at Oracle Labs.
Yes,
Still Oracle Labs?
Still Oracle Labs.
Right.
A bigger Oracle, but Oracle Labs. So.
Right. Okay. And okay. So for those like 2 people who don't know what GraalVM is, what is GraalVM?
That is a good question because it's a big project. So there is a lot to talk about, right? But in a nutshell, GraalVM is a JDK, and we add things on top of the JDK, right? So everything you need to remember is that you can use it as a JDK, like you would use Oracle JDK, Open JDK, etc. So we're not taking anything out, but we add things on top of it. So the first thing we added was the Graal JIT. We have our own JIT compiler, like you have C2 in OpenJDK. We have Graal JIT, and it's very cool because it's itself written in Java. How cool is that?
Okay, as opposite to C++, the original one.
Exactly.
Okay.
And you might ask me, but what about warm-up, right? So Java has a bit of warm-up.
Generally, why? I mean, there are advantages in writing the virtual machine in the native language that will be performance. But so why not?
Because
why
we
Java?
love Java. How cool is that?
Okay, well, that's a nice excuse, but no.
No. There is more to it. Like we love Java, but there is more to it, right?
Exactly.
One thing is, if you can choose, I mean, I love native languages, nothing wrong with them, but maybe if you can choose to write a new project, maybe we choose Java, because we have so many cool libraries out there. We have amazing tooling, we have amazing IDEs, and we do love Java, right? And you would think that maybe for VMs and compilers, there will be a little bit of performance overhead, because you want your compiler to be as fast and readily available as possible. But this is where native image comes into play. So we can take our compiler, compile it with native image, and ship in our JDK distro a natively compiled version of GraalVM. So it all
Hold on. But native image what?
Native image. So that, funny you should ask, that's another big part of GraalVM, and that is this famous ahead of time native compilation of Java, where we are taking your Java program as bytecode, so it has to be class files or a jar file, and you'll compile it ahead of time, so at build time, into a native executable that can run without the JVM. And because we compile and optimize and analyze your application at the build time, there is no warm-up overhead. It's readily available as a native application, which you still write in Java. How cool is that?
It is cool, but hear me out. I have a like a hot take.
Bring it on.
Yep. And the hot take is, like, Java was always, at least one of the aspects was that we were very, very productive in writing the language because we postponed the optimizations to runtime. The entire just-in-time compiler is about, okay, you write code, which might be not as efficient as you could write it in native C++, whatever, but in runtime, Java will make it right. It will figure out how to optimize it while it runs it enough times, and then eventually it will be super optimized. Now you say, okay, let's reverse it. Let's take more time or more processes or more generally, like we'll do more stuff at compile time and build time, and then the runtime will be faster, the startup will be faster, there will be no runtime. So, you know what? I mean, I get it. It's probably great for the JVM, but we're here in Build Propulsion Lab, and it's all about developer productivity. And I feel like, hey, you're taking from me one of the beautiful things that were about Java, that I just write it very productively, and the performance and runtime, JIT will figure it out. So yeah, I don't know how I feel about that.
Okay, that was a nice attempt of a hot take. So
I tried.
Let me address it, right? So as far as like writing your application goes, it's still the same. So you would write your application as you would for the JVM. We don't ask you to write performance optimizations manually. In fact, we feel very strongly about this. In the past, we used to have the sessions which we would call abstractions without regret, because we think that you should write code that is readable, maintainable, and a good code for you as a human being. And then us, compiler engineers, we can take care of the optimization. So we are not asking you to manually optimize code. We don't think you should be doing that. We would like to take care of that. When it comes to runtime versus build time, I get what you're saying, but also I think you can agree with me that applications are started more often than they are built. So it kind of makes sense maybe to shift all of that work to build time, and don't have to do it every single time when you start your app. Maybe you can do it once, right? But also, we understand what you're saying, and we are actually working on a new, big, exciting project. I don't know if you heard about it or not, because it's fairly new, and it will be a major deal for us. So we also care about developer productivity a lot. And we thought, okay, maybe we can improve those compilation times, because indeed, for a bigger application, sometimes it can take a few minutes, and not everyone has that attention span, right? Like, I don't have that attention span myself, right?
Exactly. Yes, thank you. It's a big deal. The difference between build that lasts a minute and build that lasts 3 minutes, you know
You get
what
out
the
of
difference
flow,
is?
right?
You know what the difference is? 25 minutes. And that's a scientific fact. Now, there is a great book by Gloria Marx called Attention Span, and one of the discoveries that she made through her entire career working on understanding attention span is that once we get context switched, and once we start checking our email, because GraalVM
Something
app
is compiling, right?
GraalVM, let's call it GraalVM is compiled too long. Yes, you're gonna correct me in a second. Then you start to do something else. The time it will take you to go back to your build is 25 minutes on average.
Restore the context, right?
25 minutes on average, and it's obviously terrible, right? So help me out there. How can we make our builds faster with GraalVM?
Absolutely. So this is something we have been continuously improving for the existing model. So right now, in my session, I was rebuilding a Spring app, so an entire Spring web application is on one dependencies, and it took 40 seconds and very little memory, maybe 2 gigs of memory. So I would say 40 seconds, that's the attention span that I personally have.
40 seconds, you got it.
But we want to make it even better. And with that, we want to introduce this big project that I mentioned, and it's called Layered Native Images. So we want to offer you a possibility to compile like a base of your application separately as a shared library. So let's say I'm working on a Spring app, I can compile my JDK base as a shared library, kind of shared library, my Spring base, and then every time I'm introducing a change, I'm only recompiling my user code. So the code that I actually wrote where I introduced the change, but the base stays the same, and it just like works against those compiled shared libraries. So I would only recompile the code that I wrote, and the rest stays compiled. And it's a development tool that we think will take build times down to a matter of few seconds, because the base stays the same. And it's one part of it, but what's even cooler, once you deploy your application, let's say I want to have 5 instances of my Spring application, I can deploy all those bases, and they can be reused between the instances on my app. So let's say I can have 5 instances talking to the same JDK base, same Spring base, same Spring web, and they can share resources, for example, in the cloud, and consume less resources because of this resources sharing. That's a major project. We are working on it, but we've seen some cool demos coming already. So maybe this year, later on, maybe next year, we will see some ready-to-use.
This sounds good. I think with that kind of optimization, I would say, yeah, my concerns will be
eliminated.
Yeah, and then the question is, why not use it for everything?
Actually, you might use GraalVM for everything. So, at conferences, people like to ask you sometimes those tricky questions. So for me, that tricky question is always like, when should I not use GraalVM?
That's exactly what I try to ask.
And my answer always use GraalVM.
Okay.
But depends on which part of GraalVM, right? So I mentioned briefly that we have a JIT. So you can use GraalVM as your JDK, and we have a very good optimizing compiler that on many benchmark is beating C2. So you can just use GraalVM as a JDK, swap your Java installation for GraalVM. That's all the migration that you need to do. And we see many people getting additional performance benefits from that. You can use it for that. You can use native image if you want to optimize specifically for startup time, for memory usage, which is like 3x, 5x smaller than on the JVM. You still have performance comparable with the JVM, and you have smaller packaging. So maybe if you want to optimize for microservices, serverless workloads, CLI tools, native image is a great shot. And I have a big vision for it that it can be on par with JVM in all the performance metrics. So we want to eventually give you this AUT at the speed of JIT for all kinds of applications. And then the last thing, you can also use GraalVM as a polyglot VM. So let's say you want to use all of the like cool Python, data science, ML stuff. You can do it from Java, and GraalVM will give you this interop and tooling for the whole thing.
This is pretty cool. How does it work with OpenJDK, with the work that other companies do, like Azul and Bellsoft and this kind of stuff?
I'm glad that you mentioned it. So we are an open source project. The GraalVM also has 2 editions, right? So we have a community edition that is fully open source, available on GitHub, and we have a very active open source project. We have a lot of contributions from the folks that you mentioned. So for example, Bellsoft, Sprint, Micronaut, and we have an advisory board with all those companies that we meet like every few months, and we talk about that with them about the project roadmap, what is coming up next. We consult with them how we should implement each of those things. We have a very active and vibrant community, and I think that's one of the great things about GraalVM. And we also have Oracle GraalVM, which is licensed similarly to Oracle JDK, that you can use in production for free and using all the cool enterprisey kind of features.
Yeah, that makes sense. But in the end of the day, if I want to use alternative JDK that is built on top of OpenJDK, for example, Azul Zulu or Bellsoft Liberica, can I plug the GraalVM as a JVM instead of C2 into one of those? Or are they combined with C2 and then there is no interop?
If you're looking for an open source distro, I would still suggest that you go with GraalVM Community Edition, because in the end, it's literally your OpenJDK with GraalC2 JIT and native image.
Okay, so that's the packaging that I'm looking for.
Maybe I am biased because I am from the GraalVM team. There are obviously other distros. So Bellsoft has Liberica, as you mentioned. Red has Mandrill. There are nice open source distros and a choice of distros in the community.
But they come with C2. I cannot swap it for GraalVM.
Mandrill does have Graal JIT, GraalC JIT, and native image, and I believe also Liberica, right? So they have the same thing. So you kind of have like flavors. But I personally would go for the version from the creators of GraalVM.
Yes, of course. But I mean, obviously, it's good to have multiple options,
especially
and it's
with
also
open source community, right?
And it's also important for commercial projects, which might not necessarily be all Oracle's clients, but still look to benefit from GraalVM and maybe with other vendors of or distros of OpenJDK. So there are options.
For sure, there are options. Whatever you choose, as long as you're using GraalVM, I'm happy. So, up to you.
There you go. Perfect. And that's what we are here for, make Alina happy. That's the entire goal of the entire endeavor. Where, how, where do we learn more?
Yes, so one go-to place is graalvm.org. That's our website. That's where you download GraalVM. You can check the docs. You can get our both with SDK Man. If you're using SDK Man, as you should, we all know and love SDK Man, right? Just one simple command, you got GraalVM, right? And yeah, that's a good place to get started. And we also have very active community channels. And I think probably the best one is our community Slack. So we have this open Slack workspace with like 5K people. People can join conversation, ask questions, talk to our team, talk to community members. So if you need any help or like consult or just talk to fellow GraalVM fans, that's a good place to go.
That sounds great. You have GraalVM.java?
Sorry?
GraalVM.java.
No, GraalVM.org.
Come on.
But that's a good point. Maybe we should.
I mean, you know that it's only Oracle who can use this top-level domain, and we cannot use it, which is a bummer, but at least you should.
Okay.
Yeah, no, but by next time I expect GraalVM.java to at least forward to GraalVM.org. Alina, thank you very much. It was a pleasure. And you all stay tuned for more goodness and awesomeness like this one at Build Propulsion Lab at JCON Europe, coming to you live from Cologne, Germany. Thank you.
Thank you so much. Bye.